Hello everyone. In this video we will discuss about the solutions of exercise 9.1 of NCERT for class 10th. That is based on the applications of trigonometry. We have already learnt about the concept, about the theory of this particular chapter in my previous video, that is heights and distances, in the full course on trigonometry. When we see the first question here for exercise 9.1, that is a circus artist is climbing a 20-meter long rope which is tightly stressed and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. First of all, we have to understand the question, and then we have to draw a diagram, a figure for this particular question. So what we do, we draw a diagram considering this AB as the pole. This is the pole. Height of this we have to find out. Consider the height of this as h. A rope from the top of it has been tied to the ground. We consider this point as C. The angle made by this rope BC, this is the rope, is 30 degrees with the ground. So we write the angle as 30 degrees. We have been given the length of the rope as 20 meters. It means BC is 20 meters. So we write what has been taken in the particular diagram. So we write, let AB be the pole and AB is equal to h. This we will consider the height of AB is h. BC be the rope. Therefore, it is given that BC is equal to 20 meters. What we have to understand is what side of the triangle has been given to us and what we have to find out. Here this pole AB is the perpendicular for this particular angle of 30 degree, and this is the hypotenuse. What is the relation between perpendicular and hypotenuse we have? We have P upon H is sine theta. It means we can apply sine theta in this particular figure. So we can write in triangle ABC, sine theta equal to perpendicular, that is AB, hypotenuse, that is BC. Then we apply the value of theta, which is 30 degree here. So this becomes sine 30 degree. AB we have considered as h and BC we have been given as 20. From the table we can see that value of sine 30 is 1 by 2 is equal to h by 20. If we cross multiply them, this gives us h is equal to 20 upon 2, which is 10. And hence we can say that the height of the pole is 10 meters. So we write therefore height of pole is equal to 10 meters, which is the answer to the problem. Now we will proceed to question number 2. Question number 2 is, a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. For the problem, we draw a diagram, and here we consider let AB be the full length of the tree before it breaks. Then we find that from point C, the upper part AC breaks, and here AC is only bending here and touching at point D on the ground. This part makes an angle of 30 degree with the ground. It means the total height AB we have to find. Now we can say that this AC and CD are to be equal. Why? Because this is the only part which is breaking and bending here. So we'll make use of the triangle and find this CD and BC both, and then we will add them to find the total height of the tree. So we write what we have described in the diagram, that is, let AB be the tree which breaks at C. The broken part bends and touches the ground at D. Given angle D is equal to 30 degree. Now we can write here, let AC be CD, and that is equal to X, suppose. So this is X and this is also to be X. And BC be H. This is the part H. Now we have to find out H and X both. But it is also given here that BD is 8 meters. So here with the given we can write BD is equal to 8 meters. For this triangle we see BD is the base, CD is the hypotenuse, and BC is the perpendicular. So in triangle, first we use perpendicular and base. We know perpendicular upon base is tan theta. And then we can make use of base and hypotenuse. We know that base upon hypotenuse is cos theta. So we will be using tan theta and cos theta in the triangle to find out the parts. So we write here, in triangle BDC, tan theta perpendicular upon base, that is h upon 8. Theta is 30 degree, so we write tan 30 is equal to h upon 8. From the table we can see tan 30 is 1 upon root 3 is equal to h upon 8. It means h will be equal to 8 upon root 3. This is the first equation. We have found the value of h. Then we use cos theta, which is base upon hypotenuse. Base here is BD, hypotenuse is CD. Theta is 30 degree, so this becomes cos 30. BD is 8 and CD we have considered as x. The value of cos 30 from the table is, you can see here, this is root 3 by 2. That is equal to 8 upon x. Then we can find the value of x by cross multiplying, that is x equal to 8 into 2 upon root 3. This is 16 upon root 3. This is our second equation. Now we can write therefore total height of tree is equal to h plus x. H is 8 upon root 3. X is 16 upon root 3. We get here 24 upon root 3. If we apply the rationalizing factor, this will be 24 into root 3 upon root 3 into root 3. We know root 3 into root 3 is 3. So this will be 24 root 3 upon 3. 3 cancels 24 8 times. So this becomes 8 root 3 meters. So we have got the total height of the tree is 8 root 3 meter, which is the complete solution of this particular problem, and this is the answer to this. Proceeding to question number 3 now. Question number 3 here is, a contractor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree. For the elder children, she wants to have a steep slide at a height of 3 meters and inclined at an angle of 60 degree. What should be the length of slide in each case? Here we have been given two cases of the same type, and we divide this particular question also in two cases. So we write in case 1, let AB be the height and BC be the slide. Angle C is equal to 30 degree and this is AB is given as 1.5 meter. So what we have to apply? In the triangle we have been given here, this is perpendicular for this angle and this is the hypotenuse. We know P upon H is sine theta. In both the cases we have to apply the same, that is perpendicular upon hypotenuse is sine theta. So in triangle ABC we write sine theta is equal to AB upon BC. The value of theta is 30 degree, so we write sine 30 is equal to AB is 1.5, BC is x. We know the value of sine 30 is 1 by 2 equal to 1.5 upon x. Cross multiplying we are getting x is equal to 1.5 into 2, that is 3 meters. In case 2 we consider the height to be PQ and QR be the slide. So we write let PQ that is equal to 3 meter be the height and QR be the slide. Here it is given angle R is equal to 60 degree. In triangle PQR we apply sine theta only, but here sine theta is PQ upon QR. Theta is 60 degree, so this is sine 60 is equal to PQ is 3 upon Y. The value of sine 60 we know is root 3 by 2, that is equal to 3 by Y. It means we are getting Y is equal to 3 into 2 upon root 3. We can write this 3 as root 3 into root 3 into 2 upon root 3. This root 3 and root 3 cancel, so this comes as 2 root 3 meters. And hence we can write therefore the lengths of slides are 3 meter and 2 root 3 meters respectively. This is the way we can find the solution of this particular problem. Question number 4 is the angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degree. Find the height of the tower. For the solution, first we will draw the diagram as we have been doing earlier also, and consider that AB is the tower and the top of it is making an angle of elevation that is 30 degree here. The point C is at 30 meters away from the foot of the tower. So we write let AB be the tower of height H. We consider the height of this is H. C be the point on the ground such that AC is equal to 30 meters and angle C is equal to 30 degree. Now here we have to find out the height. This is the perpendicular and the given is that is base. Perpendicular upon base we know is tan theta. It means in this case we will be applying tan theta. So we write in triangle ABC, tan theta is equal to P means AB, that is perpendicular, upon base, that is AC. Theta is 30 degree. So we get tan 30 degree is equal to AB means H, AC means 30. And we know the value of tan 30 is 1 by root 3, which is equal to H upon 30 here. If we cross multiply, we are getting H is equal to, replacing or transposing 30 here, we get 30 upon root 3. Using the rationalization, we get 30 into root 3 upon root 3 into root 3. Root 3 into root 3 is 3. So we get H is equal to 30 root 3 upon 3. 3 cancels this 10 times. So we are getting this is 10 root 3. Hence we are getting the height of the tower is 10 root 3 meter. Therefore the height of the tower is equal to 10 root 3 meters. This is the answer to the problem. The fifth question here is, a kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. No slack means the string is straight. For the solution, first of all we will draw the diagram. The diagram is here. This is the kite at a height of 60 meters. This is the string. The length of this is considered as y. And the angle of inclination, that is 60 degree. And we write the description. Let AB be the height of the kite. AB is equal to 60 meters. BC be the string and BC is equal to y, suppose. Angle C is 60 degree. Here what we find? We have been given the height, that is a perpendicular. We have to find the length of string, that is the hypotenuse. And we know the relation between perpendicular and hypotenuse, that is P upon H is sine theta. So in this case we will be applying sine theta. Hence in triangle ABC, sine theta is equal to, perpendicular means AB, hypotenuse means BC. Theta is 60 degree, so this becomes sine 60 is equal to AB is 60. BC is, we have considered y. And from the table we know sine 60 is root 3 by 2, that is equal to 60 upon y. Using transposition to find the value of y, we get 60 into 2 upon root 3. Using the rationalization, we get 120 into root 3 upon root 3 into root 3. Root 3 into root 3 is 3. So this is 120 root 3 upon 3. 3 cancels this 40 times. So this comes as 40 root 3. And hence we can say, therefore, the length of string is equal to 40 root 3 meters. This is the answer to the problem. Question number 6 onwards, we will continue in the next video. Subscribe the channel if you have not subscribed it so far. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.